In this video, we are going to talk about completing square. I'm going to do a complete example on how we can change a quadratic equation to a vertex form using completing squares. Let's assume that we have given a quadratic equation in the form of y is equal to negative 3x squared minus 6x minus 5. The completing squares has a couple of steps that has to be followed. First, you always group the x terms together. That's the first step. So I'm going to write this one as open bracket negative 3x squared minus 6x minus 5. The second thing is that make sure the leading coefficient, which is a coefficient of x squared, is going to be 1. Here, the coefficient of x squared is negative 3. So I'm going to factor this one out. So I'm going to have negative 3 x squared plus 2x minus 5. The next step is look at the coefficient of the term with x, which is 2 here. Divide this coefficient by 2, so 2 divided by 2 gives you 1. Square it is going to be 1, so add 1 and subtract 1 from the terms inside the bracket. So I'm going to have negative 3 open x squared plus 2x add 1 subtract 1 minus 5. And since 1 minus 1 is 0, nothing is going to be changed. Now take the first three terms. So I'm going to have negative 3 x squared plus 2x plus 1. I group them together, and then minus 1 minus 5. You always take the addition, which is here in this case is plus 1. So you don't work with the subtraction term. You always work with the addition one. Now, if you look at x squared plus 2x plus 1, this is the same as x plus 1 squared. Since x plus 1 squared is equal to x squared plus 2x plus 1. And then a negative 1 here minus 5. Now I'm going to distribute negative 3 inside the bracket. I get negative 3 x plus 1 squared. Negative 3 times negative 1 is plus 3. Negative 5. So I get negative 3 x plus 1 squared minus 2. And this is our vertex form with the coordinate of the vertex to be negative 1 and negative 2, and the a, which is the leading coefficient, equal to negative 3. And since it's negative, our parabola is going to open downward.